This video shows how to do a watershed analysis or a watershed delineation in ArcGIS. Or in Swedish, analys av tillrinningsområde. The data used in this demonstration comes through the map download service or map download interface at SLU, the Swedish University of Agricultural Sciences, and looks like this. Note that this is only available for SLU employees and SLU students. Nevertheless, the data is the geographic Sweden data from the Swedish Cadastral Authorities, or in Swedish geografiska Sverigedata från Lantmäteriet. The data I have downloaded is elevation data, and I choose the elevation data with 50 meters resolution, or höjddata as it says here in Swedish. And also for background map and for reference map, you can call it also, I used the general map, the lowest resolution map here, called översiktskartan in Swedish, because it's a relatively large area in Sweden, just north of Uppsala here, covering the merge of two rivers running south through Uppsala. Yeah, that's about it. So this is the thing I ordered and downloaded, and this is the way it looks on the disk. This is the original deliveries in zip file format, so I just extract them or unzip them. 1 and 2 can look a little bit different. I have a software called WinRAR installed in Windows 7 at least, and you can unzip them with the with Windows own tools. Anyway, we have a look at in the folders that we just created here, and the map data is inside the clip result subfolder. So here, this is the general map in vector format, shapefile format. Yeah, you can see that because it's a whole bunch of files. So we know that. So I will rename this folder to something that we actually recognize. So we recognize the contents. The other subfolder I enter the clip result subfolder, and this is raster, and it also says höjddata 50 meter, which is elevation data 50 meter in English in TIFF format. Yes. So I rename this folder simply to have a simple but descriptive name, for elevation. Yeah. Now we shift to Arcmap. I have opened an Arcmap window or document here, empty one. And now we locate the data I just downloaded in the catalog window. So here we have the general map and the elevation data, and as always it's generally a good idea to start with the background map. And deliveries from the SLU GET service or the SLU GET interface, in the clip result subfolder together with the shape data, you actually have a layer file or LYR file, and the SLU guys at SLU recently actually have fixed the LYR files, so the only thing you should need to do is just drag and drop it in the table of contents to add it in Arcmap, and it will work. The links actually works. So here you have the general map over the area I just showed you in the SLUGET interface. So that's basically the only thing you have to do to add the background map. Well, the elevation data is here in TIFF format, as we previously saw in the Windows Explorer. And it's actually a GeoTIFF format, which means that the geocode and the reference system is included in the TIFF file. So we should be okay by just adding this one also. I put it under the map, or the general map, like this. We hide the general map for now and have a look at the elevation data. This is quite normal. It displays like a gray rectangle. So we enter the properties of the elevation data layer here, the Symbology tab, to actually see the data in some form. This can be done in several ways. In this case, for stretch type, I use custom. Do you want to compute histogram? It's a good idea. Yes. Click histogram button, and here you can see the minimum and maximum value. In the data we have minimum 11 and maximum 75. Just click OK. Go down to statistics and choose from custom settings, and for minimum just type 11, for maximum type 75. Yeah. If you click OK, you should actually be able to see the elevation data. So we have bright colors is high elevation data, and dark colors is low elevation data, or areas with low elevation. Yes. The first thing you should check, or that can create problems for you, is the extensions. Click Customize and Extensions to see what extensions that you have, and what extensions is activated. So in this case you need the Spatial Analyst extension. So this should be checked. You should have a check mark in this box, which I already have. If you have not, just click here and then click Close. The other thing you should check is an option in the geoprocessing menu here, and click Geoprocessing Options and wait a few seconds. Yes. In the top of this geoprocessing option dialog window, you have an option to overwrite the outputs of geoprocessing operations. Have this checked. As default it looks like this, but you check it, and it will be easier to work with the tools. Yes, because if this is not checked, ArcGIS will refuse to overwrite previously created datasets, and this, having it checked, make life easier for you. Just click OK. Now go to the toolboxes in the catalog window and expand the system toolboxes. Here you have the Spatial Analyst tools. Here, third from the bottom, at least in my case. And inside here extract the hydrology toolset. So here you have a few tools, of which you are going to use several. The first tool you are going to use is the Fill tool, found here. Just double click it. If you get annoying ActiveX warnings, just click OK. It will work anyway. For input surface raster, just choose the elevation data you just imported and add it in Arcmap. And for output surface raster, click the browse button. It's most of the case not a good idea to just leave this, at least not the first time. So make sure you are inside your workspace. In this case I have a folder called Watershed Analysis here, and you can also see the original data here. So for name I just call the output _fill, like this. Leave the third field blank, you will be okay. Click OK, and ArcGIS will start working. You can see that in the bottom here. Okay, now you have a new raster in the table of contents, which pretty much looks like the original elevation data. What this tool does is basically to fill cavities in the elevation data. So it fills, well, so to speak, pits in the elevation data. So the following tools we are going to run will actually work. The second tool you are going to use is the flow direction tool found here. Just double click it. Oops, once more. Yes, there we have it. For input surface raster, we are going to use the filled raster we just created, or the filled raster. For output, always click the browse button, and we call the output _dir, short for direction, and leave the other things untouched. Click OK, and you see the flow direction process, and it's finished now. This is an flow. This new raster displays the flow direction. Looks very funny, and just some short information on what has been calculated here. This is an illustration of raster data in cells like this, in rows and columns. And for each cells, ArcGIS calculates the maximum down slope. So for this cell, for example, colored in gray, it takes the maximum slope from either of 8 neighboring cells like this, and it gives the flow direction in that cell will have 8 possible values, either direction representing this direction, this, and 7 and 8, total 8 possible values representing 8 possible directions. So it will take that as the modeled direction of the direction of the modeled water flow from this specific cell to the next. Yeah, we go back to Arcmap. So here we can see that in the symbology here that we have, and 1, 2, 3, 4, 5, 6, 7, 8 different colors or different values for each pixel, or each cell actually we are calling them in in a GIS. And it's very hard, of course, to interpret any useful information out of this raster, so well, we can just hide it. It will still be here. The next tool we are going to use is the flow accumulation tool found here, also in the hydrology toolset. We double click it, and for input we use the flow direction raster we just created here. An output, click browse button, and we will choose a name, flow acc in our workspace. Click save, and you will be fine just leaving the rest as the default values. Click OK. and wait for the flow accumulation to finish. Now, here we have the flow accumulation raster. It's important that you set up this symbology here to have the flow accumulation raster displayed properly, because in the flow accumulation raster there are a few but important cell values in the raster that has extremely high values, and then we have a large number of cell values with very low, near to zero values that are not so important to see. And going to the properties of the flow accumulation raster, and we have the Symbology tab here and the stretched view. You can do this also, you can do this several ways, but in this case we choose, for stretch type we choose histogram equalize is probably the fastest way to do this. And for color ramp, in this case I choose the orange from fade light to opaque, and click OK. And here we can have a quick look at the raster. Here we get lines like this, where the orange color is high values and the light values are lower values. And we can have a quick examination or a quick check here. Choose the identity tool in the toolbar called Tools here, and click here on an dark orange place like this, and you will have an identity window opened. This specific cell has a value of almost 100,000. If we click just outside on the bright area, we see that we have a pixel value of 1, and a little bit a few steps more outside, here we have a value of 0. So it's a large difference between low values and high values, and also we have a concentration of relatively few high value pixels. But they are important. It's important to have these lines displayed clearly. Yes. We could also hide all the rasters and show the general map. We can zoom out a little bit so we don't. Yeah. And here you have a number of sublayers that makes up the map. Unfortunately, the layer files is so far only in Swedish. But anyway, this is the water courses on the map, that like rivers and such. To do this, like I will make a copy of this layer and put it outside the general map, and the quickest way to do that is holding down the control button. So now I'm pressing the control button on the keyboard and dragging and dropping it outside the general map. I made a copy, it's still there, and I have a copy there. And also to display watercourses, the watercourses sometimes are too thick to be displayed as lines. So I will also do the same with the layer with water surfaces. This is also in Swedish, of course. It's sjöar is lakes in English. Now you have vattenyta, which is a water surface in English. I'm holding down the control button again and dragging and dropping it here, like this. I will hide the general map, and I will do another trick. I will select the watercourses line layer. Now I hold down the control button again, and I can select the water surfaces layer at the same time. So I have selected two layers. I right click and I choose group, and now we have created a group, and we can, for clarity purposes, we could call this water simply. So that's what it is. And I also, it's a bit complicated symbology in the watercourses layer. I will change that to just single symbol to make it simple here. And I will choose bluish color, thickness 2, and well, yeah, that's, we don't need to fix anything else. Now we have a fairly simple but clear display of all the watercourses taken from the general map group layer, like this. And if we display the flow accumulation raster again and zoom in a little bit, we can see that these lines in the flow accumulation raster, that is kind of the local flow accumulation maximums displayed, the maximum lines, actually roughly coincides with the watercourse or the rivers here. And that is quite natural because the flow accumulation model or the model used here uses the elevation, uses a surface from the elevation data and models that water runoff in the direction of the steepest downward slope. And that is pretty much what is happening in the nature or in the real world also. So the flow accumulation lines, the lines in the flow accumulation raster, roughly coincides with the rivers in the real world. Yes, and these rivers, we can show the general map again. We can hide the flow accumulation raster so we actually see what we are doing. Here, this is just outside, just north of Uppsala, a place. This is the main river that goes through Uppsala, called Fyrisån, or the Fyris River. And it is originally 2 main rivers that merges here in a point just outside Uppsala, where we have Vendelån, or the Vendel River in the west, and the eastern river is still called Fyrisån actually, and they are merging here. Hope I got the names right there. So what we are going to do is calculating the watershed the watershed delineation of each of these rivers. To do that, we actually need another thing called a point data set with the so-called pour points. So we go back to our workspace. In my case, that's the Watershed Fyris folder here. Right click here, choose new, and then shapefile here. So we just create a shapefile for point data. So the name, we call it pour points. Feature type is the default is point, and that is exactly what we like to have. We can have a look here. You can actually choose other types like polygons or polyline. But in this case, we would like to have points. That's okay. Reference system is always important to check. So we have to define it. It's not defined yet. Click the edit button, select button, project it, national grids, Sweden, and here we have SWEREF 99TM. Select that, click add, and then click OK again. So now everything should be okay. So click OK. So doing this, it will also automatically add the shapefile as a layer in the table of contents. We can right click the PowerPoint layer here and have a check in the attribute table, and we see that we have an empty table. There are no things under the field names, and we have three fields to begin with. An ID field, a field called shape, and a third field ID. You can just close the attribute table again. Remove the general map and display this water group layer we just created instead. Or actually, well, we can have a quick check. Of course, we use the flow accumulation layer. That's the one that we are going to use mainly. And again, you can check that you are on the correct place where you have the rivers. You can also have a check in the general map here. So hide everything except the flow accumulation and the pour point layer here. You can zoom in a little bit, because now we are going to add points in the pour points feature layer. And to do that, we need the editor tool, which I have already opened here. I can remove it and show you how to get it. You right click in the gray in the gray area, empty area here, so to speak, in the top of the Arcmap window. If you right click, you get all the possible toolbars that you could display. In this case, we would like to display the editor toolbar. So just click here. So here's the editor toolbar again. What you do now is click on the editor menu button on the left and start editing. And you get a window of all the possible layers that you could edit now that are present in the table of content. Choose the pour points, find the pour points and select it. Click OK. And now you should have a new window opened somewhere. I have it here. It says create features. And the pour points should be displayed here also. Just select it, single click it, and under construction tools, we are going to use the tool called point. It's just for creating new point data. Zoom in a little bit here. So here we have the merge point of the two rivers, and we are going to select a pour point on the left branch representing the western river. Go a little bit upstream, not too close to merge point. You could have problems. I will choose a pour point here, and it's important that it is on this line of maximum accumulated flow. If you put it outside, it will not work. It has to be on the line. So that is the reason why you must display these lines properly in the flow accumulation raster. So that is one point. We are open the attribute table for the pour points feature layer also, and we can see here, for example, that we have the point, a new point here. In the ID field that is automatically created for you, this is a value field with a value 0 as a default. Now change that. You can click here and edit the cell in the table. Choose the value 1. Right. Close the attribute table. Choose the editor button again, and now choose stop editing. And it will ask you if you would like to save your edits. So you will click yes. So now we have actually created a new point in the pour points feature layer here. Now we are actually ready to run the final tool called Watershed, also found in the hydrology toolset. Just double click it, and input here is still the flow direction raster here. We are not using the flow accumulation raster. The flow accumulation raster is important, but only for locating, or so to speak, where to put the pour points. So it's the flow direction raster we're using. And here we input the pour point or the pour points. It could be in raster format, but also possible to have it in vector format or feature as a feature. Just drag it here like this. So the third field you could pay attention to. If you do exactly like I did, you will have the correct field chosen here. It's the pour point field. It takes a value. You choose a field that you picks a value to identify the watershed with. So the ID field is where we change the 0 from 1 just a moment ago. So leave it like this. An output raster. Click the browse button. So we will create a new raster. I will call it eliv water short for watershed. Yeah. So now we should be okay running the tool. Click OK and wait for the watershed to finish. Now here, what I just did was that I hold the Alt button on the keyboard. I press the Alt button and I click a layer, and it will automatically do a zoom to layer. That's what I just did, and the zoom to layer could also be found here. But holding the Alt button and clicking things, it will quick away the zoom to layer. Yeah. So this is the watershed area that we have calculated, and it's where the water would run off and finally accumulate into one point here. Yeah. And also we will now add another pour point. Click editor, start editing, choose pour points. I just double click now. In the create features, select pour points and select point. Just single click. Zoom in again on this merge point here. Now we are going to select a second pour point, and that one we are going to select on the eastern branch here, just upstreams from the merge point, a little bit upstreams, not too close here. And again, important that we put it on this line where we have the maximum flow accumulation. This should be fine. We could have also again a look in the attribute table when we see here that we have a second point in the second row here. And again, go in the ID field and give this point the ID value 2. Like this. Close the attribute table, stop editing, save edits, yes. So now we can actually run the watershed tool again. We use the flow direction raster, the pour points, the same pour points, which actually where we actually have 2 pour points now instead of 1. Pour point field is still the ID field. Output raster. Now we could choose the same. Here the same raster as we just created the first time. eliv _ watershed. Now we have a warning sign here that says something about the eliv watershed raster already exists. So ArcGIS warns you that you are actually now going to overwrite existing datasets. And if we had not selected the geoprocessing option to overwrite things, this would not have been possible. It would it will then display a stop sign here. You will not be able to run the tool. Now we can run the tool. It warns you, but of course we know what we are doing. So we click OK. Watershed is processing and it's finished now. Now you might have problems like this. It does not calculate the watershed or just calculates a little bit. What you need to do is go back and open the watershed tool again. Input the same things again, the flow direction, the pour points, the ID field is correct, output raster, LA watershed. Before you click OK now, click the environments button here. And you can see various numbers or various environment settings that you can set and check. In this case, it's important to have a look here at processing extent. And with processing extent, ArcGIS means the area where the geoprocessing tools are run. And in this case, we would of course like the watershed tool to process this. Well, process the area where we have elevation data. It says default, and it's not very clear what ArcGIS means with that. And this specific problem will be fixed now if we specify that we use the same area as the elevation data. So in the bottom, at least in my case, in the bottom it says same as layer höjddata in English in English elevation data. It doesn't matter, of course. We have several layers. We could try same as layer elev fill is the first layer we produced using the fill tool. So just click OK. And the same inputs have here we have the inputs we just defined. Just click OK again, and the watershed will process. And now we're back, so to speak, but we still just see one watershed area. But it is okay. What you need to do is go into the layer properties of the elev watershed layer that we created the first time we run the watershed tool. Here, the Symbology tab here. Unique values we are showing, but you need to add all values like that, like this. Now we actually see that we have ones and twos. So if we click OK now, we will actually see the both of the watershed areas. So now we have not only the watershed area or the watershed delineation of the watershed from or to actually pour point, this pour point. We also have the watershed for the other pour point here. And the final step here would be to create polygons of this watershed areas. Rasters are of course valid GIS data, but displaying things on a map and for example displaying things on a map, we could be better off having polygons. So what we do is we enter the conversion toolset here. In my case, fourth set from the top, and we enter the from raster toolset, and here we will find raster to polygon. Open that tool. On input raster would be the final watershed raster here. Field to use, make sure it says value here. An output polygon feature, click browse button, and in my case I would call this polygon feature dataset watershed pol, short for watershed polygon. Simplify polygons is fine. Click OK, and in a few seconds now we will have the polygons displayed on the screen like this. Not close, hide. You could hide, well, you could hide everything except the watershed polygons like this. Go into the symbology of the watershed polygon feature layer, and choose categories unique values instead, and we have the ID field. Click odd L values. Well, yeah, you could uncheck the all other values option here. It's generally you do not want that. Anyway, yeah, but I'm going to do a quick setup here. I will do the one of the watersheds in a green color, so fade green surface, outline with 2 and a little bit darker outline color. And for number 2 watershed, I will use a fade blue color surface and an outline a little bit darker, like this. Yeah. So here is the watershed polygons, and we could display the general map, which is under now, like this. And here we can see it could be a good idea to manipulate the display a little bit further. Go back to the properties tab, properties of the watershed polygon feature layer, and click on the display tab. And you could, for example, choose a transparency of 40%. Click OK. Like this, you could actually see the map also under the polygons like this. Another option would be then to just displaying the outline, not the surface. Could also be a good choice. Well, yeah, this is pretty much how to get the watershed delineation in ArcGIS. Thank you.